Good morning. Today we're going to figure out the formula for the volume of a cone. But to be able to do that, we're first of all going to have to use our volume of a cylinder. Let's take a look. Here's what you have to have. You have to have a cylinder and a cone, and you're going to notice some relationships about these two. The height is the exact same for the cone and the cylinder. The other thing that's the same is the diameter. So with these two things staying constant, we're going to be able to figure out the relationship between a cylinder that we already know how to find the volume for, pi r squared times height, and now we'll be able to find the formula for our cone. So to do this, I've got some nice food-colored blue water, and we're going to see how many of these cones will actually fit into one cylinder. So based on this information, can you already make a prediction? How many cones will fit into our cylinder? If you guessed 2, it is more than 2. And there you have it. You can see that 3 cones that have the exact same height and the same diameter will fit perfectly into one cylinder. So let's go back. Let's go back to our equation then. So if a cylinder is pi r squared, what is the formula then for a cone? What is the relationship of one cone to a cylinder? If you said that yes, we can fit 3 cones into a cylinder, you are almost there. 1 cone would be 1/3 of a cylinder. So it would be pi r squared times height divided by 3. There you have it. Now you're going to be able to go figure out the volume of your cone for your piñata. Have a great day. Okay, let's look to see how we actually use the formula for a volume of a cone. If you remember, it is pi r squared times height, which is a cylinder, divided by 3. So let's go ahead and just look at a cone. We'll go ahead and give us the diameter here. We'll just say that the diameter is 6 centimeters and the height of this cone is 8 centimeters. Those are the two things that we need. We need the radius, which we can get from the diameter, and we need the height. So if we're going to solve the volume of how much this cone could hold, we would take volume equals pi times our radius, which is half of our diameter, so 3 squared, times our height, divided by 3. Now I can take pi, 3 squared is 9, times 8, divided by 3. And if I wanted to solve this, I would just take 3.14 times 9 times 8, press equals, divided by 3. So 1/3 of this cylinder would have been 75.36, which would have been the cone. And that would have been centimeters cubed. So the top part is for the cylinder, pi r squared times height. And then if you remember from earlier in our experiment, there's 3 cones in every cylinder. So that's why we had to divide by 3. Okay, So what I did is, the only cone I had is the snow cone cup that my boys used to use when they sold snow cones. So this is the only cone I have in my house. You can also make one if you go and you Google cone net. And you should be able to get a pattern so that you can actually make one for your piñata if you don't have any other kind of cones that you can use. So let's go ahead and look at this one. I'm going to have this cone setting on its base. And if you're trying to actually measure a real life cone, the diameter is fairly simple again. We're just going to measure straight across, and it looks like it's 8.2 centimeters. And the height is going to be really hard to measure. So what I'm going to do is I'm going to measure the slant instead, and we'll use Pythagorean's theorem then to find the height. So the slant is 11.5. So this measurement here, which is not the height, is 11.5. So we're trying to find this height of the cone. Do you see the right triangle that has been created? Let me redraw that right triangle. So my hypotenuse, which is the slant of my cone, is 11.5 centimeters. And this height will cut the diameter directly in half, leaving us with the radius, which is 4.1 centimeters. So now I know the hypotenuse and a leg, so I can easily go through and use Pythagorean's theorem, which, if you remember, is a squared plus b squared equals c squared. So I'm going to use my calculator. 4.1 squared is 16.81 plus b squared, and then I'm going to square 11.5, which is 132.25. Now, to be able to get b squared, I'm going to subtract my 1681. So b squared equals 132.25 minus 16.81, and I've got 115.44. But now remember, that's b squared. We only want the height, so we're going to square root this. And b, which is actually my height, is 10.7 centimeters. So this is representing my height of my actual snow cone. So now I can go ahead and find the volume of this snow cone cup. It's pi times the radius, which I've already found over here, so 4.1 squared, times the height, which is 10.7, and I'm going to divide that by 3. So let's go ahead and see what we get. Pi times 4.1 squared times 10.7. I'm going to press equals and then divided by 3. My volume is 188.3 centimeters cubed for my snow cone cup.